there. Today we're starting a new chapter called conic sections, and conic sections basically are all the different shapes that can be created with the intersection of a plane and what we call a double napped cone. So to begin with, if you just look at a few of these pictures, in this first one, if you take a plane and slice it through the cone, it's going to create a cross section of a circle on that plane. If you come through it at an angle, it's going to be more elongated and it's going to be an ellipse. If you slice it through the base of the cone, then it's not going to be kind of an enclosed fixture, it's just going to keep going on. That actually is a parabola shape. And then the fourth conic section is when the plane slices through parallel to the altitude, and that's where it's more of a double napped cone. Next example. A double nap cone means it's one cone inverted on top of another, and when you do this parallel, you create these two little arcs. They are not actually parabola shaped, but they're kind of like that. But since there's two of them, it creates what we call a hyperbola. Okay, so those are the four conic sections, and each day we'll do a new one. Today we're going to do circles. And depending on who studied conic sections, they can be looked at geometrically like that cone. We also can look at them as a set of points, and circles are all the points that are equidistant from one particular point called the center. So in other words, if I had a center point right here, oops, that's a little bit big. Let's try again. Here's my center point, and I want all the points that are, let's say, 4 centimeters away or whatever, and so I'd say, oh, here's one that's 4 centimeters or 1 centimeter, it looks like it's more like, and here's one that's 1 centimeter, and here's one that's 1, here, this would be about 1, and I just sit here and I start creating all the points that are 1 centimeter away, and it would eventually create a nice circle with a radius measurement of that 1 centimeter. Okay, so let's look at what we already know. We talked about circles earlier in the year, and so you should know the formula for the area of a circle, where HK represents your center, but it's also kind of that whole shifting game that we have learned. This H moves it left and right because it's with the X. Since you're inside the parentheses, it's always going to be the opposite of that. So if it's a minus sign, we're actually going to have a positive movement. The K is actually tied in with the Y value here, and so it's going to shift my circle up and down. And again, since we're in parentheses, we'll do the opposite sign. R is going to be the radius of your circle. So back to what we have previously done, could we write the circle if I give you the center and the radius? Okay, ideally, yes, you should be able to do that. The equation of your circle is just going to be an x minus 4 squared plus, and then you'd have a y, and it's the opposite sign, so it's a plus 2 squared, and it's going to equal my radius squared, so it's going to equal 25. Now, I'm going to do kind of an example of as we kind of gradually give you different information. So kind of each one of these will just be a little bit different, but that's kind of the gist of it. We're just trying to get the center and the radius put in there. Ideally, you could go the other way with that as well. So if I give you the equation, could you write the center and radius? Could you graph it? So ideally, yes, you could. The center on this, if you look with the x, it's a plus 3, so my x value is a negative 3. On the y value, it's a minus 2, so I'm going to have a positive 2. And then the radius is going to be the square root of whatever it equals. So in this case, it's going to equal 9. All right, let's try one that's a little bit different. In this case, notice it just says x squared. Anytime you don't have anything in the parentheses, that actually just means that your center value doesn't move that direction. So my x value will be a 0. My y value is going to be a negative 9. And then the radius, don't always expect that to be a nice, pretty, perfect square over there. The square root of 40, I could write it as the square root of 40, but I'm going to probably reduce that to a root 4 and root 10. So that really the radius would be 2 root 10. Depending on what you're doing with that, you might have to go decimal. If you have to graph that, then you're just going to plot where the center is and then go up and down whatever that radius is, and left and right, that'll get you 4 points. But 2 root 10, I don't really know off the top of my head, so maybe I have to get a decimal approximation. On your homework, it asks you to answer it as a radical, exact, and as a decimal. So you'll want to do both of those. That's approximately 6.32. So again, if you have to graph it, you're just sitting there looking at that, maybe like on this top one. I would go left 3, up 2, I'd plot that point as my center, and then I'm going to go up 9 and down 9 and right 9 and left 9 and get those 4 points and try to make that look as much like a circle as you can if you have to graph one. Okay, let's try something where I give you something different. I don't hand it to you quite as easily. It says write the equation of a circle whose center is the origin and it goes through the given point. Okay, so if the center is the origin, then I'll know my h and my k, but what I'm going to have to do is figure out what the radius is. Okay, so this one has a radius, or it has a point. I know it's centered here, and it goes through over 9 down to, it goes through somewhere right here. Well, if I need to know this radius, I'm just going to do a little distance formula. So we'll be doing distance formula several times on these circles to find that radius measurement. So refresh your memory on that distance formula. We're going to have, and we're going to find the distance between the origin and the point 9, negative 2. So remember, it's x minus x squared plus y minus y squared. So the distance is going to be, this is going to be 9 squared, so that's 81. This is negative 2 squared, that's a positive 4. So the distance between the center and that point is the square root of 85. Well, that distance is also the radius, okay? So if I know my radius and they told me it was centered at the origin, I should be able to write my equation. I'm going to have x squared, because I don't have to move it left or right, plus y squared, not moving it up or down, equals my radius squared, which would end up being 85. So there's the equation of that circle. Let's try another one. Actually, this one is the same thing. I was going to give you one to try on your own where you have to go find, giving the same thing. It's centered at the origin, goes through this point, you go write the equation. So I'll wait a minute while you try this one on your own. Okay, so hopefully this is what you got for that example. Okay, this one says write the equation of the circle with endpoints of the diameter given. All right, so they're giving me the endpoints of the diameter, which is not the center or the radius. They didn't really give me either one, so I'm going to have to work to find both of those things. So let's just sketch this real quick to see what's going on. Over 4 down 3 is about right here. Left 2 down 8 is somewhere right here. And those are the endpoints of my diameter. So my circle must look something like this. Okay, so with that, I need to find two things. I need to find the center, and I need to find the radius. So let's start with the center. What do you suppose is special about the center in reference to these 2 points? And hopefully you're saying, oh, that's going to end up being the midpoint. So you need to know your midpoint formula from earlier in the year. So remember, to find the midpoint, you add your x's, divide by 2, add your y's, divide by 2. So that's what I'm going to do with these 2 points. Add the x's, so 4 plus negative 2, and then divide that by 2, and then I'm going to add my y's and divide by 2. So the midpoint, or the center of my circle, is going to end up being, let's see, that's 2 divided by 2, that's a 1. And here I have a negative 11 over 2. So you might want to go decimal on it if you want. Negative 11 over 2 would end up being negative 5.5 or 5.5. And so if you sketch that over here, if I go over 1, down 5.5, yeah, that seems pretty reasonable for my sketch. So that is the center of my circle. Now we're going to work on finding the radius. The radius is the distance from that center that you just found to one of those endpoints. Now, don't find the distance between the two endpoints. That's your diameter. Now, the diameter is just twice as long, and you could just find the diameter and then divide by 2, but you'll find what you're getting for that distance doesn't always divide by 2 nicely. So I would highly recommend always do the center to one of those endpoints. So I'm going to work on this, and I'm going to do the distance from the center that I just found and to one of those endpoints. I'll go ahead and use the 4, -3. And I'm doing the distance between those. So distance equals square root of x minus x squared plus y minus y squared plus, okay, so this ends up being plus, here I end up with a -3 plus 5.5 is 2.5, squared is 6.25. And so I'm going to end up with the square root of 15.25. All right, so then my last step is to write the equation. All right, I'm kind of out of room here, so I'm going to squeeze this in. So my final answer would be, going back to the center, that midpoint, so it's going to be x minus 1 squared plus y plus 5.5 squared, and that's going to equal, and I'm out of place, sorry, kind of cluttered, it's going to equal 15.25. Remember that you have to square that radius so that square root goes away. Okay, let's look at one where we have some application involved. So this one says, suppose there's an earthquake that could be felt 30 miles from its epicenter. Okay, so you're located at a point 18 miles east and 22 miles north of the epicenter. Do you feel the earthquake? If so, how many miles north would you have to travel to be out of range of the earthquake? Okay, we're going to do a lot of these types of problems, so I need you to kind of pay attention, take some good notes here, maybe watch this one twice if you're a little bit iffy on it. So the first thing I want to do is just sketch a picture of what's going on. And I'm just going to center this earthquake right here at the origin. That will make my life easier. So then anywhere within here, inside there, people can feel the earthquake. If they're outside of that circle, they can't. And it says that the radius of that is 30. So I know that there's 30 miles there, radius on my circle. And then the next, so really with that, I should be able to write the equation of my circle because I know where it's centered and where the radius is. Okay, but let's hang on to that idea and let's look at the other part of this. It says you are located 18 miles east and 22 miles north. And we're trying to figure out if you are in there, inside that circle or not. So 18 miles east, 22 miles, I don't know, it could be here-ish, or it might be above that. I'm not sure which one it is. So that's the question. How do you decide if you are within that or outside of that? Okay, so I'm going to go to a new screen and we're going to look at this a little bit bigger so you have more room and you can see better what's going on. Okay, so remember that equation of the circle that we could write for this, since it's centered at the origin, the equation of our circle would be x squared plus y squared. And it equals our radius squared, so 30 squared would be 900. That equation represents all the points that are on the circle. So any point on the circle would fit in that equation. Now, my point is probably not on the circle, so I'm not expecting that to be there. But what I'd like to know is what this point right here would maybe be, the one that's straight north of that. So I know that the x value of that point would be 18. I just don't know how far up it is. Is it more than that 22, which would look like it from my picture, or am I actually outside of the circle and it's smaller than 22? Well, it's actually pretty easy to figure out because I have the equation. If I plug 18 in for x, let's see what the y value is. So on my calculator, I'm going to take 900 and subtract the 18 squared. And I get 576. Square root that. And I get 24. Okay, that's pretty lucky. Not always going to end up with a nice, beautiful, perfect square there. But, or that's just a y, not y squared anymore. Let's erase that. So y is equal to 24. So what that means is that ordered pair that falls on the circle is 1824. Meaning, yep, I'm lower than that. I'm not as far north. I'm only 22 miles north. So I'm inside. I can feel the epicenter, or I can feel the earthquake. And then the second question was, how far north do you have to go to get outside of the earthquake? Well, I'd have to go from 22 to 24. So that would be, if I just subtract those, 24 minus the 22, which again, this is easy to do in your head. Don't expect that to always come out nice. But I have to walk or drive or whatever 2 miles north to get outside of the range of that earthquake. All right, so we'll do some other problems that are kind of similar to this. Sometimes we'll be inside the circle, sometimes we'll be outside of the circle. Make sure you have good notes on this problem. It's going to come back a bunch of times.